Enthusiasts, welcome back to our channel. In today's video, we will tell you why the production of the popular V8 semi-truck engine was quietly phased out at the end of the 80s, as well as the advantages and disadvantages of the V8 and why all manufacturers now only use inline-six engines. So, let's dive right into it. Back in the 1960s, it was possible to choose a V8 engine for your semi-truck. Here were popular models like the Mack E9, Peterbilt 359, Kenworth W900, Freightliner WFT, and International Transtar 430 were some of the models available. One of the most popular V8 engines was the CAT 3408. It was first introduced in the 1970s and discontinued around 1985, but is still used in marine vessels, power generation, and construction. Today, all truck manufacturers use inline-six engines, and there are several reasons for that. One of them being that inline-six engines typically have longer strokes, which result in higher torque output. The longer stroke allows for increased displacement, enabling the engine to generate significant power. Today, the engine is so thoroughly developed that it's possible to extract so much horsepower and torque from the inline-six engines that there is simply no reason to go up a size in the V8. As an example, the strong Detroit DD16 can deliver up to 2,050 pounds per foot and 600 horsepower, and the Cummins X15 up to 2,050 pounds per foot and 605 horsepower, which is more than enough, especially taking America's limit of weight into account, where the federal limits are 80,000 pounds gross vehicle weight. The European truck brand Scania still produces V8 engines with up to 770 horsepower and 2,730 pounds per foot, but several countries in Europe also have a permitted total weight of up to over 200,000 pounds, which is why the extra horsepower and torque may be necessary here. The reason why interest in V8 engines decreased was also for economic reasons. The inline-six engine's longer stroke and higher torque output allow it to operate at lower RPMs while maintaining performance. This lower RPM operation contributes to improved fuel efficiency, making it advantageous for long-haul applications where fuel consumption is a major concern. The inline-six engine's fuel efficiency can result in reduced operating costs for trucking companies. It's not only the fuel consumption which is higher on the V8 engine, so is service and maintenance cost. Inline-six engines are generally easier to service and maintain compared to engines with a V configuration. The inline layout simplifies access to engine components, including injectors, valves, and camshafts. This ease of serviceability reduces downtime and maintenance costs, ensuring more efficient operation of the truck. But V8 engines are also more complex and have more parts. For example, they have two camshafts, one for each bank of cylinders, and multiple valves per cylinder, resulting in a more complex valve train system, and of course, 2 cylinders more, which result in more and higher maintenance expenses. In addition, V8 engines typically also had a significantly higher initial price than inline-six, as it is expensive to manufacture and develop this type of engine, and therefore costs more for the consumer. Also, the inline-six engine has a longer and narrower profile compared to V8 engines. This design allows for better packaging within the truck chassis, maximizing available space. The longer shape of the inline-six engine facilitates easier installation, serviceability, and maintenance access, which are crucial factors in the trucking industry. Another big part of why manufacturers stopped making V8 semi-truck engines was due to emissions regulations. As environmental concerns grew and emission regulations became more stringent, manufacturers had to focus on developing engines that complied with these regulations. V8 engines generally have a higher displacement and produce higher emissions compared to inline-six engines. To meet the emission standards, Truck manufacturers shifted their focus to inline-six engines, which offered better emission control technologies and fuel efficiency. The emissions standards are tightened year after year, and the trucks are allowed to emit virtually no emissions. This has great costs for the manufacturers, who must constantly develop and improve their engines.